If you've built pretty much anything on the cloud, you've used Amazon S3. It's a given. But here's the thing. Just using S3 and using it well, those are two completely different things. Today, we're going to pull back the curtain and show you how a couple of small changes in your thinking can transform S3 from a frustrating performance bottleneck into an absolute data superhighway.
So let's start with a scene I bet is super familiar to a lot of you. You're pushing data to S3, everything is going great, the progress bar is flying, and then bam, performance just hits a brick wall. Your upload's slow to a crawl, and you're just sitting there, scratching your head, wondering what on earth just happened. And then you see it, that dreaded error, HTTP 503 slowdown. Now, this isn't some random network hiccup. This is a very, very specific message from S3. It's basically telling you, hey, you're pushing too hard, but you're pushing in the wrong spot. This error is the key, the main symptom of the exact problem we are about to solve. Your first instinct, right? It might be to just throw more network bandwidth at the problem, maybe get a bigger instance. But that won't help one bit. The solution here isn't about raw power. It's about understanding the fundamental way S3 is designed to handle data. It all comes down to architecture. Okay, so let's get into the secret sauce. The entire key to unlocking S3's real performance potential comes down to understanding one single critical concept, the S3 object prefix. Seriously, if you can wrap your head around this one idea, everything else just kind of falls into place.
So, what in the world is a prefix? Well, for starters, it is not just a fancy name for a folder. It's the very first part of your file's name, what S3 calls its object key, that the internal S3 machinery looks at to decide exactly where, on its absolutely massive infrastructure, your data is going to live.
And this requires a little bit of a mental shift for us. You know, we see slashes in a file path, and our brains are hardwired to think folders and directories. But S3 doesn't see that. That whole folder structure is really just an illusion, a nice little convenience for us humans. Under the hood, S3 sees a flat world of logical partitions, sometimes called shards. And that prefix? That's the address that tells S3 which partition your object belongs in.
Okay, so let's see this in action. Let's look at how this one idea can completely flip your application's performance on its head. We're going to see how a really small, simple change in how you name your files can make a gigantic difference.
So, on the left, we've got a super common pattern, especially for things like log files or IoT data. Everything's organized sequentially by date and time. The big problem here is that the prefix, that logs/part, is the exact same for every single object. Now look to the right. That's the fix. It's so simple. Just by adding a short random hash to the beginning of the key, we've created totally unique prefixes for every file. So why does that work? Okay, think of S3 partitions like checkout lanes at a grocery store. The sequential pattern on the left, that's like sending every single shopper to the exact same lane. You're going to get a massive line, a huge traffic jam, and a big bottleneck. But the randomized pattern on the right, that's like a smart manager opening up thousands of new lanes and directing people to all of them evenly. The load gets spread out, and everything just flows.
And listen, this isn't just some abstract theory. There are hard numbers here. Amazon has documented performance guidelines. A single prefix, which means a single partition, is built to handle up to 3,500 write requests per second. We're talking puts, posts, or deletes. If you try to jam more than that into one prefix, S3 is going to hit the brakes and throttle you. That is literally when you see that slowdown error.
And for reading data, so GET or head requests, the limit is even higher. We're talking 5,500 requests per second for each prefix. The takeaway here is so clear. If you need more performance, you don't need a bigger, more expensive S3 bucket. You just need more prefixes.
Okay, so randomizing prefixes is the absolute game changer for handling tons of small files. But what about the exact opposite problem? What's the best way to deal with one single massive file? Let's talk about another pro-level tactic. Right, this is a whole different kind of performance challenge. When you're dealing with files that are hundreds of megs or even gigs in size, a single upload stream can be painfully slow. And worse, it's fragile. If that connection breaks when you're 90% done, guess what? You often have to start all over again from zero.
The answer is a beautiful feature called multi-part uploads, and it's probably already built into the AWS SDK you're using.
First, it takes that huge file and slices it into smaller, more manageable parts. Then, and this is the magic part, it uploads all of those parts at the same time, in parallel. Once all the pieces arrive safely on the other side, S3 just seamlessly stitches them back together into the original object. And the performance boost here is no joke. By using all of your available bandwidth at once with these parallel streams, you can see upload times drop by as much as 40%. It's huge. Honestly, for any file over, say, 100 megabytes, this should just be your default way of doing things. So we've talked a lot about the logical side of things, prefixes and partitions. But to really get why this all works so well, it actually helps to peek inside the machine and see the physical hardware that makes all this incredible scale possible. You see, S3 isn't a one-size-fits-all system. It's not just a pile of hard drives. It's a really sophisticated, hybrid system that intelligently uses different kinds of storage, like old-school spinning disks and modern solid-state drives, playing to the unique strengths of each one to get this perfect balance of cost, capacity, and speed. So on one hand, you have traditional hard disk drives, your HDDs. They're super cheap and can hold massive amounts of data, which makes them absolutely perfect for storing the actual bulk content of your files. But on the other hand, you have solid-state drives, or SSDs. Their secret weapon is near instantaneous seek time, which makes them ideal for storing all the metadata and indexes S3 needs to find your data in a fraction of a second. And this is where it all comes together. All of this physical hardware, the spinning disks, the flash memory, it's all organized into those logical partitions, or shards, that we were talking about earlier. This is the bridge that connects the physical hardware to the logical prefix. It allows S3 to automatically monitor everything and rebalance data behind the scenes, making sure no single piece of hardware ever gets overwhelmed.
Okay, so let's bring all this home. Let's boil it all down to the most important lessons. Because if you're building on S3, thinking about how you architect for performance right from the very beginning is going to save you so many headaches later on. So if you remember nothing else from this, remember these 3 rules for S3 performance. Number 1, S3's entire performance world revolves around the object prefix. That is how it partitions data, full stop. Number 2, to get insane throughput for lots of small files, randomize your prefixes. Spread that load across as many partitions as you can. And number 3, for any big file, just use multi-part upload. It's the best way to max out your bandwidth.
At the end of the day, what we've really learned here is how to work with S3's design instead of fighting against it. And that's a powerful lesson that goes way beyond just this one service. So the final question I'll leave you with is this. Now that you can see this pattern in S3, what other hidden bottlenecks, based on how a system fundamentally partitions its data, can you now find in your own cloud architecture?